Good evening to you viewers and welcome to another video. I must say to you that I'm extremely ecstatic for the level of responses that I've been getting. The comments have been wonderful. I thank you for your comments. I thank you for watching the video. And I just want to say I truly appreciate all my viewers and my subscribers thus far. So for today, in this video, I'm going to be talking to you about how to interpret your foundation plan. Okay? I'm going to be looking at how you can determine what is right from what is wrong and how can you better able to execute when it comes to your foundation drawings. So without further ado, let's get into the video. Thank you. Welcome back to this segment of my presentation. I know that I've said to you in my intro that I'm going to be talking about reading of your foundation plan, but there are a set of additional abbreviations which wasn't included in my presentation last week that I think is worthy of note. I think they are worthy to bring to your attention. So let me just quickly go through these additional presentation and then I can move on to my main topic of discussion, which is reading your foundation plan. So the first one we have here is cast in place, okay? And then there's in situ, okay? Which means cast on site. Now, these two terms, CIP and in situ, they can be used interchangeably, okay? But you will more see CIP cast in place in the American system. In other words, when you're looking at a set of building plan or a set of bridge plan, you will more see cast in place. That is under the American system. Now, in our system, the Jamaican system, we are under the British system, and you will more see in situ, which means cast on site. Now, these two terms is just in relation to your pouring of your concrete on site, okay? And then there is NTS, which is not to scale, okay? We have EL, which means elevation. PS, which means pre-stressed concrete. We have FC prime, which means the compressive stress of concrete. We have YS, which means yield stress of steel. We have HT, which means high tensile steel. And we have BFE, which is bottom of footing elevation. And we have MSE, which means mechanically stabilized earth. Okay? But I must point out to you that some of these terms you're not going to see on your typical building drawings in Jamaica. In other words, you're not going to see them on your residential. You might come across some of these terms when you're dealing with industrial or commercial building, but for the typical residential building in Jamaica, the typical residential plan in Jamaica, you're not going to see these terms, okay? You more see these on plans that has to do with bridge or industrial or commercial building, okay? I just want to point out these to you, okay? So this is it for abbreviation. This sums up abbreviation. If in the event that I came across any more that I think is worthy, I will bring those to your attention as well. So without further ado, I'm going to go into my main topic of discussion, which is reading your foundation plan. Thank you. Welcome again to this aspect of my presentation, and I'm going to be moving right into my presentation about reading your foundation plan. So let me get right into it. So therefore, as you can see now on my screen is the foundation plan for this building, okay? So let me point out to you, last week I mentioned to you that in terms of drawings, your floor plan is the most critical when it comes to drawing purposes, okay? But when it comes to building the building, the actual construction of the building, your foundation plan is the most critical of them all, okay? If your foundation fails, your structure fails, okay? The foundation is responsible for carrying all the gravity loads of the structure, meaning your dead load, your live load, plus the self weight of the building itself, okay? And your foundation, if it is not constructed properly, you can find yourself in problems in terms of structural failure, in terms of shear cracks, and in terms of flexural cracks that develop in your structure. So you must take care to read your foundation plan very carefully. In other words, you must study your foundation plan. Okay? So point to note that your foundation plan, and I hope you're seeing my cursor here. So let me say this again. When you're reading your foundation plan must be read in conjunction with your foundation details. In particular, your footing details. Okay? So because the foundation plan, what you're going to observe, and the first thing you should observe when you're looking at the foundation plan is the width of your trench. And I hope you're seeing my cursor going around this here. This is 600 millimeter or 2 feet wide. So your foundation plan will show you the width of your trench. Secondly, and a very, very critical aspect of the foundation plan, you must study your location and your placement of your stiffener columns, okay? And I've shed some light to you last week, the role of your stiffener columns as it relates to your building, okay? These are very, very vital components. They are structural elements that is there to preserve the structural integrity of your building. So your location and your location of your stiffeners is very, very important. Okay? Second to note that when you're reading your foundation plan, you must ensure that you read the dimensions carefully. Okay? And your dimensions must correspond with the dimension on your floor plan. Similarly, your stiffener layout and placement must be consistent with the stiffener layout on your floor plan. In the event that the architect or the draftsperson have a stiffener layout on your floor plan, it must be consistent or the same as what is indicating on your foundation plan. Okay? Because I have seen where inaccuracies can come up, because if the stiffener plan, if the stiffener is not layout is not corresponding with the stiffener layouts on your foundation and plan and on your plan, it can cause problem, because I've seen where stiffeners, it can affect a door opening, it can affect a window opening, it can affect a opening in general. So you need to ensure that your stiffener layout and your foundation plan is consistent with your stiffener layout on your floor plan. I can't stress that anymore. Okay? This is vitally important. Okay? You must also read your foundation notes. Okay? And your foundation notes is contained in your general notes, because plenty of times, and as you can see here, all excavation should be approached by the engineer before placement of any steel. So as I said to you before, the foundation notes, right, contain pertinent information, okay, that the contractor or the builder must know, because you can come upon you while you're excavating, you can come upon soils that are not suitable, okay, to carry the load, the gravity load of the building, okay, and that soil probably, cannot carry the the weight of the building. In other words, it is the bearing capacity of that side is not strong enough, right, to carry the weight of the structure. So all these informations is contained in your general notes. So you must read your foundation notes when you're excavating your foundation. Okay. Another point to note, okay, is that when you are finished studying your foundation as it relates to the width, the width and the length, the dimension of your floor plan, your placement and location of stiffness, you know what I mean? Your scale and all that. Make sure to observe your scale, because I've said to you before, dimension that are left off, you can use your scale to obtain those dimensions. Okay, so you must ensure that all these, and carefully read your foundation plan, because in it too, it can tell you, what the floor is going to be reinforced with. You know what I mean? Many times we know we use BRC mesh. Okay? So after you have critically looked at your foundation, then you must move over to your footing detail. Okay? And this is very, very critical now. Your footing detail. So while you have gotten the width of your trench from your foundation plan, your footing detail is going to give you your depth of your foundation. So as you can see now, this depth here of this foundation is 3 feet. Okay? 3 feet minimum. Okay? Meaning that you can go further, deeper than 3 feet, but you must not go less than 3 feet. Okay? Your minimum depth is 3 feet. Okay? Also, you must take into consideration your concrete cover. I can't stress this, because I've seen a lot of buildings in Jamaica that, people who are building these buildings, they're not paying enough attention where your concrete cover is concerned. Okay? Your concrete cover is there to protect the steel from moisture getting to the steel and corrode the steel. Okay? Okay? And in an advanced way, your cover is there to protect your reinforcement from chemicals that are corrosive to the steel, like chemicals such as chlorine, okay, such as pH, your potential hydrogen, right? Your potential resistivity and your sulfates. Okay, all these are very, very corrosive material that can corrode your steel and compromise your building, compromise the structure of your building. Okay, so you must pay attention. And notably, when you're going below ground, it's best to have your cover 3 inches. Okay, your concrete cover, your concrete clearance 3 inches, and above ground you can have 2 inches. 2 inches to cover your steel, but your steel coverage is very, very important. Okay. Also, you can observe from your footing details your width of your footing. Okay, and your placement of your reinforcements. Okay, so you look for those call outs of your reinforcements in your wall footing detail. Okay, as I was saying to you about your wall footing detail, okay, your wall footing detail is very important, okay? So you must pay keen attention to your rebars column, okay? Your vertical reinforcement, okay? And your horizontal reinforcement, okay? And one critical component that I'm going to point out to you, from an engineering standpoint, how you can check your width of your wall footing and your thickness of your wall footing, or you can check and see, if it is conformance with engineering principles. You can check by multiplying your wall thickness, okay, times 3 to come up with your width of your foundation or your width of your footing. Your width of your footing is 3 times the thickness of your wall. Okay? That's your minimum width. It can be more, but not less. Okay? It can be more, but not less. And that's why many times when you look at a typical wall footing detail, you will see the width is 1 foot 6 inches. Because how they get that 1 foot 6 inches, they multiply the thickness of the wall, which is 6 inches, by 3, and they get that 1 foot 6 inches, which is 18 inches. Okay? Your thickness of your footing now is very, very critical also, because your thickness of your footing is to resist against what is called punching shear. Okay? Your thickness of your wall footing should be designed to resist the wall itself, due to its weight, from punching through the thickness of your wall footing. Okay? So, therefore, your thickness of your wall footing, as it shows here, is 9 inches. Okay? And that 9 inches is obtained from multiplying your 6 inches thick wall by 1.5. Okay? So 1.5 times 6 inches, you're going to get 9 inches. So always remember, your minimum width of your foundation footing is 3 times your thickness of your wall, and your thickness of your footing is always 1.5 times the thickness of your wall, which is 6 inches. That is how we get the dimension to be 1 foot 6 inches against 9 inches thickness. The reason why I have 2 feet 0 inches here, I spread my footing a little bit wider to get more stability. And as I've mentioned to you before, the wider your footing, the more stable your structure. Okay? And remember, as I said before, your footing is supposed to receive the gravity loads, meaning your dead load plus your live load plus the self weight of the building must transmit down to your wall and to your footing. And what the footing does is spreads that load evenly across the foundation. Okay? So the wider your footing, the more stable the structure. Can remember, stress is equal to force over area. And when you increase the area of your footing and divided that area into your load, that if your load doesn't change and you change your width of your footing, which means you're going to change the surface area. When you divide that area into your load, you're going to end up with less stress, providing the weight of the wall or the building remain constant. Okay? So that is key to note. And also, if you look at the base of the footing here, you're supposed to cast a blinding layer of 2 inches thick of Class C concrete. I want to say Class C concrete, it doesn't mean that the concrete has to be rich as it is poured for your footing. And as I'm speaking about concrete mix, your concrete mix is supposed to be the strongest going into your footing. So you should use a mixed proportion of 1 to 4, as against 1-3-6. Always use 1-2-4, which is a stronger mix to pour your footing. Okay? So, with all that said, you can now move to what is above your ground line. So this GL here means ground line, and this FFL means finished flow level, as I pointed out to you in my previous presentation when I talk about abbreviation. So if you notice, your finished flow level from your goal line is 1 foot 6 inches. Also, you must take in consideration what material you use for your consolidated fill. Okay, your consolidated fill must be compacted at every 8 inches lift, meaning you spread your material 8 inches and you use your compactor and compact it. You go up another 8 inches, you compact again, you go up another 8 inches, and you compact again until you reach the required thickness. Okay, and also you should notice your floor slab, which is reinforced by your BRC mesh. Okay, so you must carefully study your wall footing, because I said to you before, it is the most critical structural component of your building. So you must study your foundation plan in conjunction with your footing detail. And after you've done that, then you can move over to your stiffener detail. You just observe the type of reinforcement that goes into your stiffeners. You know what I mean? It is usually the stiffener is usually the same thickness as your wall thickness. So there's nothing much into that to really study, but just observe. And also you can observe your column detail, because your column detail is going to be a part of your foundation detail. So you must look at your column detail in section and look at your column detail in plan. Okay? And if you do that, you're in good order to execute a well constructed foundation. So with all that said, that pretty much wraps up as it relates to studying your foundation plan. And in my future videos, we're going to be talking about elevation and how you can read elevation properly. So if you like the video, hit the like button, share, and subscribe. And I talk to you again in my next upload. Okay? Thanks.